Now, are there any questions over any of the assignments thus far? Well, assignment, the one that we had yesterday. Now, what we're looking at today is logarithms. So what an actual logarithm is and kind of working with some of the properties. Now, a logarithm really, and especially we'll get to this at the end of this section of notes, is the inverse of an exponential. Is the inverse function of an exponential. So we can change it from logarithmic to exponential or exponential to logarithmic by using this here. Let b and y be positive real numbers with b different than 1, so we can't have a base that's equal to 1, kind of like what we talked yesterday with exponential growth and exponential decay. Then this is true. Log base b of y is equal to x if and only if b to the x is equal to y. So this statement's true only if both of these do work. So we can switch from one to the other. So log base b of x equals y if and only if b to the y is equal to x. So let's look at this here. So the first few that we're going to do is just really switching from log base to exponential. So the first one we have is log base 2 of 16 equals 4. And as we've said, log base b of x equals y if and only if b to the y is equal to x. Now looking at this first problem, what is the base for this here? What is our b in this case? 2. So the b in this case is 2. What is our y value in this case? Y is taking the place of 4. 4 is taking the place of y. And x is 16. So y was 4 and x is 16. So the exponential for log base 2 of 16 is equals 4, would be 2 to the 4th is equal to 16. Now with these here, we can check it. Because I can grab a calculator and say 2 to the 4th power is 16. So that is the correct statement, and we will eventually be able to check some of the logarithms. Now the only way we couldn't check or wouldn't be able to check this is if the 4 or 16 was a variable. So if we said 2 to the x equals 16, we can't check it because we don't know what the value of x is. We could figure it out, but we'd actually have to know all the value spots. Now let's look at the next one. Log base 4 of 1 equals 0. In this case, our b would be what? 4. The y for our exponent would be 0 is equal to 1. 4 to the 0 is 1. Anything to the 0 power is indeed 1. We can check it. 4 to the 0 is 1. So we do have the correct statements. Questions on how we found either one of these here? Are you ready for the next ones? So we want to rewrite log base 12 of 12 equals 1. So we'd have what? As an exponential, our base is 2 to the equals 12. And we do know this is true. 12 to the first power is indeed 12. Now let's look at the next one. Log base 1/4 of 4 equals -1. So what's our base in this case? 1/4. We can put parentheses around it. So we have 1/4 to the what power? Is equal to 4. And again, if we plug this into the calculator, we will indeed see that that would be true. Questions on either one of these here? We good with this here so far? Let's look at the next one. Log base 6 of 216 is 3. So this would be what? 6 to the third is equal to 216. How about the next one? The base would be 7 to the equals 1. The next one, log base 21 of 21 equals 1, so 21 to the first is equal to 21. And lastly, log base 1/5 of 5 equals -1 would be 2. Any questions on how we went from logarithmic to exponential? We ready for the next one? Now we're going the other way around. And it still holds true. So we could say b to the y equals x if and only if log base b of x is equal to y. So for the first one here, we're going to have log base what? Log base 5 of, because what's inside would be x, yes? It would be 25 is equal to 2. Because the b in this case is the 5. X in our case is taking the place of 25 and y is 2 because b to the y equals x. Y is in the exponent, so 2 is our y. X is what this is equal to, so 25, and our base is 5. It's just going backwards. So if we look at b, 10 to the -1 equals 0.1. So we'll start off with log. Base what? 10 of 0.1 is equal to -1. Now if we want to, we don't have to. We can put parentheses around the number inside the log to signify that it is in the log. I will do this especially on the test and to make sure that you know what is inside the logarithm, because it is known that we say log base 10 of 0.1 x plus 3. The plus 3 is actually not inside the log because the parentheses aren't around the 0, the whole thing. It's really just saying this here plus 3. I put the parentheses so that we know for sure what's actually inside the logarithm and what is not. But we'll get to more of those later on. Any questions on rewriting these as logarithms? Let's look at the next one. 8 to the 2/3 is equal to 4. So we'd have what? Log base what? 8, yes. Yes. Yes, the terminology is new because we're not used to it. But log base 8, because again, we talk about a base. Base is whatever number we have to an exponent. So 8, log base 8 of 4 is equal to 2/3. Let's look at the next one. 6 to the -3 is equal to 1 over 216. Log base 6 of 1 over 216, or 1 2/16 equals -3. Questions on any of this here? So we'll do 4 more and then we'll move on. So if we look at the first one, 9 squared equals 81 would be log base of And that's it for the first one. The next one would be log base 20 of 0.05 equals -1. Next one would be log base 16 of equals 3/4. And the last one, log base of 5. Questions on any of these here? You can put them, you cannot, just especially if there's one term, it's neither here nor there. But if you feel better with them, I would. I would make sure that the base is written as a base, that is signified that we can tell for sure it's a base, and that we're not writing log 981 is equal to 2. So we need to signify that that is the base. It needs to be lower, yes. Lower and a little bit smaller. Because it seems like that's not a big deal. However, there is an understood base with logarithms. So if it looks like this one here, log 9 times 81 is what it really looks like. And we'll get more into this later, because if we don't write a base or doesn't look like we write a base, it's actually understood to be 10. The understood base for logarithms is 10, and it's what we call the common log. And when we get into some more of the properties, we will talk about something called change of base, changing it into common logarithms. Any questions on any of this here? Now this seems a little strange, especially why are we doing this here, especially going back from exponential to logarithm or logarithm to exponential. Now for the most part, it's dealing with solving exponential functions. Now if I said 2 to the x, you don't have to write this down, is equal to 8. Well, 2 to what power is 8? 3. We're good with this here. We can say x is 3. This is fine. If we said 3 to what power is 9, we know x is 2, yes? These we're good with. Now if I said 3 to what power is 10, is there a nice number that we can put 3 to get 10? Well, according to logarithms, log base 3 of 10 would be x. These logarithmic functions give me a way to actually find out what the value of x is. Now for this here, it's not a nice number, but we will get into actually solving these here in a minute. The calculator will let us do this. Now the yellow calculators, the 30XS, don't have, they do have a logarithm button, and this one here has it too, LOG, but this is dealing with common logs. But if we hit math and scroll down, it does have log base. So we could say log base 3 of 10 for this here, and C at 2.0959 going on is the value of x that would make 3 to it be 10. So there are ways that we can do this, and that's why logarithms are nice. So any questions on this here? So we kind of see why this works and kind of helpful. Now, we're going to evaluate these logs. Now, there's 2 things that are very nice. One, log base b of 1 is 0. Whenever we have 1 inside the logarithm, no matter what the base is, it's going to be 0. Because if we rewrite it as an exponential, we're saying b to the 0 is 1. There's only one exception, is that the base cannot be what number? 0. Base can't be 0. The 0 to the 0 is not 1. It kind of throws everything off. Now the other one that's helpful is log base b of b. If the number inside the logarithm is the same as the base, the value is 1. Because if we rewrite this as an exponential, we're saying b to the 1 is equal to, well, itself. So if we looked at these here and kind of worked these out, log base 4 is 64. I'll get off the eraser. Base 4. Well, 64 is 4 to what power? 4 to the third. So we do have a base, b to a base. And what they're going to say is that we can rewrite this as log base 4 of 4, the whole thing to the third power. Well, log base 4 of 4, as we've seen already, is, well, actually that's not be helpful. Yeah, because we have 3 of them. So we're saying that we have it once, twice, 3 times, and each one of these is 1, so the whole thing is 3. Now, there are going to be ways that we can get to this, especially tomorrow when we talk about product property, product, quotient, and powers that will make these easier to work with. So it works out that log base 4 of 64 is 3. Now in the calculator, we can go math, log base 4 of 64 is 3. And we could use the properties or this here. So log base 5 of 0.2, so I can get the calculator and say log base 5 of 0.2 is -1. Because what they're saying and using for this here is log base 5 of 1/5 is -1. Because that would be log base 5 of 5 to the -1. Then our log base 5 of 5 is 1. We would technically bring the -1 up front and get -1. The next one, log base 1/5 of 125. If I want to cheat, I can grab this here. Bless you. Alpha y equals enter 1 over 5. I need to remove that 5. Is 125. Enter. We get -3. Questions on this here? We like this so far? Log base 36 of 6 is, should be a half. Six, 36 is 0.5 or 1/2. Questions on any of these here? Do we feel comfortable typing these in? We're kind of working through that there. Now, again, as I've said before, we're kind of on a time crunch. I would have normally gone through a little more in detail, especially how we can break these down and use our properties to get there. Do we feel comfortable with these here? Natural logs are the other type of logarithm that we deal with. They're the same as logarithms. They just have a base that we call e. So they have an understood base e. We don't write it, but it's understood to be e. Now, I don't know why they did this, but these are called natural logs. I don't know why they didn't denote it as NL instead of LN. It's confused me, I don't know. But they may have just ordered it alphabetically, which is weird. We don't do that with other things. So here, it's still, so here it's ln. Now, the way that we switch it is still the same as we did with logarithms, because log base b of x equals y is true if and only if b to the y is equal to x. So in this case, our base is e, so e to the y is equal to x. So for this here, I'm writing it so that we see it, but when we do it, so, and we'll see it when we do it, we don't necessarily have to write it, because if it's understood, we don't have to put it there. So it's this, so we just need to know it's there. It's the same as putting x to the first power. We know that it's there, we don't have to put it. Or putting the 2 inside of a square root. We just know it's there, we don't have to. Now, for these here, so ln of x equals y, if and only if e to the y is equal to x. So our first one here, ln of 6 equals x. So this would be the same as e to the x is equal to 6. Questions on this first one here? Let's look at the next one. ln of 5a, this is all contained inside the parentheses, it's all together, is equal to b. How would we rewrite this? E to the b is equal to 5a. And that's it. Yeah. Yeah, now with ln, I will always use variables, especially when we're going from one to the other, because if we remember e is an irrational number, a non-repeating, non-terminating decimal. So no matter what we put e to, whatever it's equal to would have to be an approximation. We can't get the actual value. So a lot of times when you're switching between the two, they'll use variables because otherwise we're giving false statements, unlike the first ones. So let's look at these next two. ln of 42 equals b would be e to the 42 is, yes, e to the b is equal to 42. And the next one, e to the 6 equals z. Now, this one we could actually type in, because if I go second ln 6, we get 403.4287 going on and on. That's kind of why they use b, because that's not a nice number. We'd have to approximate. Yes. Any questions on these here? So let's go the other way. E to the 2x equals y would be of ln of y equals 2x. The next one.
Is the y supposed to be a base?
So.
How is that supposed to be written? Oh, I see.
Yeah. So we get this here. Now the base is here. It's just e.
Right.
Yeah. Ln. So the natural log base e of y is 2x. So we don't have to write the e. We can just say the natural log of y is 2x. And that sometimes is confusing that we can just drop the base off. Here we would have ln of equals 57. Questions on this here? Do we need to see another example of one of these? Now, we're getting into this here. Evaluate log of 8 or the natural log of 0.3, round to 3 decimal places. These are the natural or the common logs because they don't have a base written. It's understood to be 10 for log, e for ln. So the first one, okay, log of 8. Since it doesn't have a base, we can grab either calculator and hit the log button. 8 is 0.903. round to 3 places. So this is 0.903. And that's it. Questions on this here? Natural log. Again, I can grab the calculator and say ln of 0.3 and get negative 1.2039, so negative 1.204. And that's it. Questions on any of these here? Now, do we need to see another example of typing these in? Because these here, especially if there is no base, we can use either calculator. We can just hit the log button and go from there. If it does have a base, we have to use the graphing calculator and do log base at this point. There is another way that we can do it with common logs, but we'll have to learn the change of base formula first. There is a way to do it with change of base, but we haven't got there yet. So we feel comfortable with all this here. Okay. Because both of these here are just plugging it into the calculator and going from there. And incidentally, log of 98 should be just under 2, I believe. .99. Well, okay. Now, even though it's not written, the base is 10, yes? Let's just say it equals x. If I rewrote this as a logarithm, we would say 10 to the x is equal to 98, yes? 10 to the first power is what? 10, yes? 10 squared is 100. 98 is just under 100. So if 10 squared is 100, the value of x should just be under 2. So now log of 9.8, 9.8 is just under what? 10. What power of x would give us 10 for 10 to the 10th? 1. 10 to the first is that. So log of 9.8, the value should be what? Just under 1. Is yeah, because 98 and 9.8, we divided it by 10 to get to it, yes? So we're just moving the decimal one place, or removing the 1 from it. Yep. Questions on these? Inverse property. So as I said at the beginning, logarithms and exponentials are inverses of each other. Now we can use this property here, log base b of b to the x is x, and b to the log base b of x is x. So here, b to the log base b of x simplifies out, leaving us with our exponent. We kind of saw it earlier. Log base 4 of 4 to the third was 3. The b and b simplified out, leaving us with the 3. We can do the same thing the other way. B to the log base b of x gives us x. Okay? We kind of see how this works. It's a little weird, but it is true. Now I'm going to apply it. Log base b of x is equal to y. Okay? So this here we can add in just so we know that this is true. Now if I apply a b, this to the base b, according to this here, log base b of b to the x is x, just what's inside, yes? So the entire left side of this here is going to reduce to x. What's inside the parentheses, yes? But can I do something to just one side of the equation and not the other? No. If I apply a base b to the left-hand side, I have to apply it to the right-hand side, which tells us x is equal to b to the y, yes? Okay, now the question is why I'm showing you this. But what did we say? Log base b of x is equal to y if and only if what? If and only if b to the y is equal to x, yes? By applying a base b to both sides, we simplify the log out, yes? Telling us x is equal to b to the y. Well, isn't that what we said at the start of the hour was true? This is part of the reason we can do it. We can go the other way too. Because if I start out saying that b to the x is equal to y, well, I can apply log base b to both sides. I'll write it back out, telling us log base b of b to the x is equal to log base b of y. Well, as we see up here, log base b of b to the x is equal to log base b of y. So this is one way we can convert from one to the other. We can use the trick that we have for converting the two, or this here. Either way works. Does this make sense? And when we start solving, we'll use both of these here to really solve and get the logarithms by themselves, or get rid of the logarithms. Questions on any of this here? Because this will bring us into the almost last part. Now the first one here, 10 to the log of 4, well, the base is understood to be 10. If it's not written, it's understood to be 10. Well, the base and the base of the log are the same, so this will simplify out, leaving us with what's inside the log, which is 4. Now I can do this in a calculator, 10 to the log of 4, and get 4. So any questions on part A before we look at part B? Now this one here needs a little rewriting. Now 25 is the same as 5 squared. 25 is the same as 5 squared. Any questions on how we rewrote 25 as 5 squared? Now the reason we're doing this is because I want the base and what's inside the log to be the same. Now we have 5 and 5, yes? Well, log base 5. Powers of powers multiply. So like I said, we have log base 5 of 5 to the 2x. Well, now the base and what's inside the logarithm are the same, so it's going to reduce to our exponent, which is 2x. So log base 5 of 25 to the x is actually just 2x. Because log base 5 of 5 is 1. Now we will get into our power property, which states any exponent inside the log can actually be moved to the front, and then we're multiplying by it. But any questions on this here? We good with this here? Now A is a little bit easier than B, but what would we say 10 to the log of 18 is? 18. Because the base, even though it's not written, is understood to be 10. So with LOG, if the base is 10, we don't actually have to write it, just like with natural logs in E. Now we do have to do some manipulating with the next one, log base 4 What do we need to change 16 into?
16 would be 4 to the 2, and this is still to the x, which actually tells us that we have log base 4 of 4 to the 2x, which is,
Incidentally, still just 2x.
So why do we have to change it?
It's to make the bases be the same.
the base and what's inside both be
4, so that we have
this kind of log base b of b to the x is
x. Now, we can't necessarily type log base 4 of 16 to the x in the calculator, but if we did type log base 4 of 16 without the x, it would tell us that it is 2, and then we have the x with it. So we'll look at these three here. Now, the first one, 8 to the log base 8 of x. Well, the number we're putting the log 2 and the base inside the log are the same. So this
all reduces out, leaving us with what?
x. Questions on this here?
The next one, log base 7 of 7 to the negative 3x. Base and what's inside it are the same. So all we have left is negative 3x.
Now the question is 2 to what power is 64?
So what would we guess? 2 to what power?
8 is, that's a little big.
We got what we wanted.
Yeah.
So it'd be 2 to the 6 to the x, which is the same as log base 2 of 2 to the 6x. So it'd be exactly
6x.
Any questions on 13 through 15?
Are we good with 13 through 15? Now we haven't brought this one up. E to the ln of 20. What do we think this would be? What is the base of ln?
E. So we're saying E
To the ln base e of,
20, yes?
does this look similar to ones that we've done before?
Kinda.
How about 13?
Do 13 and this one have a similar setup?
So would it just be
It would just be 20.
Because the base here, what we put it to, and the base of the logarithm are the, so E to the ln would reduce.
Questions on any of this here? We will do 2 of these here. These here on the homework will be bonus. So if you do them, I will give you a bonus point for each one. If you don't, that is fine. Finding the inverse of each function. So we're using our properties that we've done so far. So again, just like with finding inverse, we replace f of x with y is equal to 6 to the x. The next thing we do is switch x and y, telling us x is equal to 6 to the y. Now, to get y out of the exponent, we're going to do what we're going to do is change it from exponential to logarithmic.
So
What we've been doing at the start.
So rewrite it as a logarithmic. So we'd have log base what? Log base 6 of x is equal to
That's the inverse. Because as I said at the start, exponentials and logarithmics are inverses of each other.
yeah. So if we are given an
Exponential to begin with, its inverse is going to be a logarithm. Now, if we're given a logarithm, its inverse is going to be an exponential. Now, they already gave it to us as y equals. So the first thing we need to do is switch
x and y.
Now, since we are starting in logarithmic, to get the inverse, we need to switch it from logarithmic to exponential.
So the base would be
E to what?
e to the is equal to
Y plus 3. Now, we can't circle it and say done at this point because is y by itself. So we need to
subtract 3, telling us y is equal to e to the x minus 3. Okay.
questions on any of this here. So that's it. Now, there are a few of these on the homework, but again, they're bonus. I'm making these here bonus. Yes, 41. So if you were to find these here,
I have to start in the middle, and I have to go to the trachea and do all of those. And I had to go over here and actually axis those.
if you were going to work these out, these is what these would be.
But y'all have a good rest of your day.